Good morning, everybody. Thank you for coming in. I know it's always hard to join a group after you've had a plenary session and then you have a coffee break. So we appreciate that you came in to hear about the life and times of disruption. We're going to do a panel today on the day in the life of operations. What we want to talk about is the way in which we recover from disruptive operations. What are the hindrances to that recovery, and what causes it? And I think there's some surprises in this. At the end of the presentations, we're going to then try to have a conversation. And the conversation will be more wide-ranging than the presentations themselves. And we would like, to the degree that you're comfortable, for you to participate in that conversation. I do have a way of seeing your questions. I know you get to vote on this. This is a small enough group where we might not necessarily want to just only use the iPad. So feel free to stand up. There's a microphone in the walkway, or if you just raise your hand and ask a question, that's fine. If you'd like to move down to be closer to the panel, that would be great as well. Today we have four really, really competent, capable, and inspiring people who deal with this every day. Our first speaker will be Tim Campbell. Tim is the Senior Vice President for Air Operations of American Airlines. So I want you to think about that for a second. That we're talking about a huge airline where disruptions happen. The only thing commonplace is disruption of some kind, someplace. We have Jim Kreitz. Jim is the Executive Vice President of Dallas-Fort Worth. That airport has got as much volume and capacity constraints as any airport. It's very difficult for him to have an operation with disruptions that doesn't affect San Diego and LaGuardia. That airport clearly is reflective of the systemic needs. Next to Jim is Brian Quigley. He's the Managing Director of Flight Operations for United Airlines. Pilot perspective, flight operations, and how that system views the integration from the airline and also from the pilot perspective. Very consequential. So far as you look at the folks that we talk to, you realize elements of the common system. They all play in the disruption recovery, and they play in it differently. Next to Brian is Dan Smiley. Dan and I go back a very long time. Dan is with the FAA, and he gets some of the most important at FAA air traffic control system. You realize that the air traffic control system for the three of his colleagues on the panel are their production line. So when there's a disruption, Dan has to figure out how that system recovers. Again, he's looking at it from a different perspective. They tend to want to look at it as one to many, and Dan looks at it as many to one. When they're done with their presentations, I think there's an ability here to have a really robust conversation. And I think an interesting one. Like it to be fun, but it's kind of a tough subject. So for them, there's not a lot of humor in disruptive operations.
Gotta have it though. Yeah.
So with that, Tim, if I can turn this over to you to start us off.
We've got our clicker over here. There we go. Well, good morning, everyone.
Good morning.
It's a real pleasure to be here. I was joking with some of my colleagues. It's taken me 32 years, I think, since I first joined AIAA as an snot-nosed aerospace engineer in Ann Arbor to finally be able to present in front of AIAA. So this is a real honor. And I never thought I would be talking about system disruption. I thought that I'd maybe be talking about aerodynamics or airplane design, but this is an equally interesting and challenging problem. So what I wanted to do is really start talking about disruption and try, at least point to the fact that not all disruptions can be handled in the same way. Winter disruptions are handled quite a bit different. I mean, they are very complex, but we usually get a more predictive path, and we have more time to prepare than we do in other disruptions. And the folks that we collaborate with, because you'll hear a lot later on about collaboration, depends on the type of disruption. In winter operations, there's typically a lot more coordination with our airport partners. In fact, the first time I met Jim when I came to American as part of the merger, we were talking about winter disruptions and preparing DFW for more of a all-weather response, and so typically talking about snow removal and de-icing. And I'm also, by the way, trying to approach this problem as I think of the AIAA and think of it from an optimization, from an engineering standpoint. So I'm not going to really be talking about hardcore airline operations as much about the technical problems, because that's what interests me the most about it. And so when you think about the constraints and the inputs that you're using, in a winter operation, the snow removal and de-icing capability is a key input. But then if you turn it over to thunderstorms, now we're in an entirely different environment. And those of you who are in the Dallas area know we have that quite a lot. And so we have very limited ability to pre-plan. We generally will know that the atmospheric conditions are ripe for disruptions, but we don't know when, and we know even less about where or for how long. In that case, we're working with Dan's team quite a bit. We're dealing with ATC and airspace and routes that are being shut down and an ability to get in and out of the airport. Whereas in the snow event, it's more about surface treatment and gates and so forth. And then when we have numerous diversions, now we're talking diversion recovery, and we're metering in flow back into the airport. So they're quite a bit different. And in fact, the problem, as I've noted here, and all of this gets around the customer. And so we feel, and I'm sure Brian would agree, and Jim as well, that we can serve the customers better in a winter operation because we can pre-plan better and we can reroute customers and give them more notice. Whereas, unfortunately, customers are experiencing more taxi delays and things of that nature with our thunderstorms. Okay, so Neil talked about how we are a big airline, and so I tend to joke that irregular operations are regular operations for us. Pre-merger, you may have had 3 hubs, and they were geographically dispersed. Now with the merger and the consolidation in the industry, the 3 major carriers, as you can see from our diversity here, it's very possible, especially during the summer, we could have a 3-4 hub event. So when you're doing problem solving and you're doing optimization, you're not just solving one hub. And that's, Neil mentioned that about the interaction and the system impact, that what's going on in Dallas and Chicago has a huge effect on the East Coast. Or airplanes getting trapped on the East Coast are now not able to come into Dallas, and if we're trying to plan metering and recovery for Dallas for their event, and we don't know what the flow is coming into the airport, it's very, very difficult to plan for that. So like as I indicated, we could have 3 to 4 hubs. The scale is pretty impressive. Each day we're the size of some small airlines. With our regional partners, we carry about 6,700, or conduct about 6,700 flights, about 500,000 passengers a day, 1,000 mainline aircraft, and almost 600 regional aircraft. So you think about that, I'll talk later, that gets to the inputs. That's part of what you're solving, part of the 3-legged stool of optimization. And that's what I'm talking about here. I've been doing the optimization piece for a while, and the nirvana for ops is what we generically call ops solver. Many of the folks in the industry, in fact some of the vendors here, may have crew solver optimization to be able to repair crew pairings in the most efficient way, operationally and an economically efficient way. But there's far more complexity involved, because we also have to think about the aircraft, right? Because we could sub-optimize the overall solution if all we focused on is what's the most crew-effective solution to a problem. Because if we don't get the aircraft into their overnights or we don't do the maintenance on them, then they're going to not be good for us the next day. So we're going to have a different problem on our hands. So when looking at solving the problem, we've now introduced the fleet element. And as I said, it's not only our 1,000 airplanes, but it's also the 600 airplanes for our regional partners, because our customers don't care who operates the certificate. They buy a ticket on American Airlines. And then ultimately it's the customers, right? And ideally we would like to, I would start with that, but it turns out that I think this is an area that we have the least information in terms of how we plug it into the system. Because we have, even now at my airline, we have something called a customer delay index, which is a way of trying to take in more of how many people are on the airplane, right? Because we know passengers are not homogeneous. There are certain passengers that have higher value than others. There are people and they're ranked either by the monetary value they bring to the organization, but it might be folks that are off to a cruise where if there's only one flight a day, and if they miss that flight, they're not going to get to their cruise. It could be some other considerations. And folding that into what I call the three-legged stool is a very complicated problem. And before you even get into the optimization, you need to have really, really good tools for rebooking and notification. Because even if you don't optimize very well, you need to you can take care of the customer by trying to give them as much notice as possible, giving them rebooking opportunities, notifying them in advance so they're not finding out while they're at an airport. And I know for myself, and I don't want to speak for Brian, we still have a ways to go just in notification, much less optimization. And so, as I said, and I think you're going to hear from Jim, you want all these tools to work seamlessly through all the disruptions and minimize those disruptions. So here's an example. I'll go through it real quick. I mean, you kind of know the drill with a winter operation. We had a forecast that had light snow starting in the morning, and then was going to be turning to rain later in the day. And that was supposed to be a multi-day event, and that we had information not only from Jim's team in terms of their ability to take care of the runways and the taxiways, but also from our team in terms of being able to de-ice regional and mainline aircraft. Well, you know where this is going. The actual weather didn't pan out that way. We had the snow began on time pretty much, but it converted to freezing rain really even before the end of the freezing day. Or the end of the day, and then we ultimately under-forecasted the precipitation and the operational complexity. So when you're trying to size the operation, as I said, in the winter, you usually have more of an advance notice. You still have to try to figure out when the weather is going to start ramping down, so you can start figuring out when you can start running a full schedule. Well, we underestimated that, and therefore, had we known that in advance, we would have taken more cancellations in advance to give our customers more advanced information, and ended up getting behind the Powerball. So and ultimately, if you compound that with some actual operational impacts, the de-icing throughput was lower than what we had planned. And I won't go into the reasons for that, but essentially the basis upon our plan was less throughput on the de-icing pad than what we had anticipated. And ultimately, it was you have to fold in not only that capability, but also your gate supply, right? Because your input and output from the airport is a function of how many gates you have and whether you can park airplanes and so forth. And so if you don't have that ability and that predictive nature, you have a very difficult time accurately forecasting departure and arrival times. And if you do that, you start getting sequencing problems, right? When you think airplanes are going to be gone and they're not gone, when you think they're going to arrive and they're not arriving, and you're trying to predict crew times and passenger connection times and aircraft touch times. So, but the good news is Jim's team delivered. The issue that we had that day was purely on American Airlines and our planning. So you'll hear a little bit more about this from Brian, but this is not an excuse, but part of the changes that were made in the federal air regulations on flight duty and rest that were effective in a couple years ago, we're still working through it, whether it's through our systems or through interpretations or whatnot. But that has added another layer of complexity in terms of accounting for pilot time and figuring out in real time how much flight time or how much duty time they have. And if you're not on top of that, you can get into, and we have, and hopefully none of you have experienced it, but we'll have a cancellation or a return to gate because the pilot's flight time or duty time is about to exceed because they didn't get off the end of the runway as fast as we anticipated, or whatever the situation may be. More and more, it sounds really untechnical and unsexy, but we can have the best modeling capability for de-icing or some of the other systems, but if our employees can't get to work, we've ultimately found our constraint in the optimization problem. You ultimately literally get down to how many employees do I have to operate the gates or to operate trucks. And in an icing event, that's very, very difficult. And when you get into each state handles it a little bit differently. We've learned the hard way in Charlotte that they're pretty quick to pull the trigger on an emergency, snow emergency, and the governor shuts down the roads. And it's kind of hard to fault your employees for not coming to work if there's a snow emergency. So that becomes a very difficult problem to get our arms around. And then again, if you don't have really robust customer self-serve and rebooking tools, then we are behind the power curve. And if you have those individuals going to reservation systems, now we're disrupting customers for future bookings and so forth. So those are the complexities with which we're dealing. I'll just flash a couple tools. I mean, ultimately these, I'm just showing some of the decision support tools or really situation awareness tools. The top one is, and everybody has these type of tools, which is, we happen to use Airborne, which is essentially like, you know, a bird's eye view of the airport. We can put a lot of information on here, a lot of tactical information, and really keep track of airplanes and spray times and overall production on the airport. I like it because it has what I call a TiVo feature, so we can go and replay scenarios and learn from them and work with our partners to see what we could do better. The next is a tool we use to try to forecast gate demand and as how we size the operation. The other is our diversion tracker and keeping an eye on where all of our airplanes are and all the various statistics we need to monitor, not to mention where they are at in their ability to recover, so we know what airplanes are ready and we can start planning their arrivals and recovery back to the hubs. But as I said, when you also layer on top of those tools other planning inputs, one of them, like I said, is de-icing capability. You'd think, how many airplanes could you de-ice in an hour? Well, it's not that simple. And this is not meant to be read, it's really meant to show the complexity. You really need to know, one says, what's my demand for aircraft, the other says, what's the event going to be? Because my holdover times and what I can do with the airplanes are completely different if it's a light snow versus a freezing rain. So we use 4 categories of events, and that has an impact on what type of de-icing fluid we use and how much de-icing fluid we use. And that gets to holdover times. And then it gets to how many trucks are you going to use, or what type of airplane you're going to use, so that you can see just figuring out a simple, what's my throughput from a de-icing pad becomes a pretty sophisticated table lookup. And if we get that wrong, it also means we planned our throughput wrong. Now I'm talking about convective, and again, I won't go into this in a great deal, but it's very faint on this schedule, but if you look in each of those graphics, there was roughly a box, and those are the 4 corner posts that guide the flow in and out of Dallas. And it's very important for us because those are the gateways into the airport. And so with a convective storm, if those corner posts get shut down, we have to work with Dan's team to figure out how to route the traffic and often turn the airport around. And you can see in this particular case, we had precipitation and lightning over a 6-hour window. And all it takes is a lightning detection on the ramp, and the ramp's closed. And we shut down the ramp. And then, so essentially that storm went, lifted north and east, but then a short while later, we had another wave that just popped up in the atmosphere, redeveloped, unforecasted, and set a whole nother level of complexion or disruptions. Now you could potentially double divert people, right, who had been on the first diversion, thought we were getting them in because we didn't have this weather. Now the weather pops out, and then they've diverted again. Fortunately, I don't think there were very many of those, but those are the things that just drive us crazy in trying to plan a network operation. So as I said, the successful management of IROPS, irregular operations, is very complicated. From a system standpoint, from an engineer standpoint, you're dealing with a wide range of tools, but they're not integrated often, right? They're from disparate companies, and then you are also trying to confusing the employees with a whole host of tools, and constantly trying to keep them trained and at least to a proficiency level for those key tools. And then you really need to know the bottlenecks. It's just like constraints analysis, right? I mean, it's basic engineering. You need to know what the operational bottlenecks are before they happen and figure out ways to mitigate them. And as I said before, exceptional customer reaccommodation is vital, as is a crew trip repair. So as we said, our goal, our overall goal, and I think this is what Neil was talking about, is trying to contain the event when it comes to weather events to the current operating day. Because generally customers will understand if you've had bad weather for that day, but in the past when we didn't do a very good job, if the cancellations and disruptions. So our overall operating goal is to contain it for that given day. And I'll just hit this real quick, and we can cover some of this in the questions. But essentially, the themes for legacy airlines like mine and for United, with people with deep subject matter expertise, is the plan and the tools are only as good as the data that goes into it, right? And so, as I indicated, when you have bad data, the old garbage in, garbage out, and it sounds really, again, not very technical. But if you don't have accurate flight times, including estimates like estimated time of arrival, estimated time of departure, and an estimated time of repair for an airplane, your plan it's very, very, very difficult. And it's also very difficult to notify customers. So set aside all the optimization in the world. If you don't get the basics down, you can't do a very good job of operating in that kind of environment. And one of the things that Brian and I were commiserating before is the legacy infrastructure that is in place for our key operating systems are decades and decades old. And they're a quilt of patches that have been put on through various contract negotiations or other issues that have come up in our industry. So, a word for the vendors here is you can come up with the greatest optimization tool in the world, but if it doesn't integrate into our systems, it doesn't do us any good. And each of our systems, by the way, are different. So from a vendor standpoint, you're doing a lot of customization and a lot of customized integration that ideally we would love to avoid, but just have never got to the point in the industry of developing a standard to simplify that. And there's very, very few people who really understand the full picture of how those interrelate. So, and essentially, even if you solve all those hurdles, you still have the people side of it. And we're dealing with that with our merger as well. And I know in the next gen technology, all of us here are involved in the next gen activity that we heard about earlier, and the change management aspect of bringing technology in is huge. It's, as engineers, we understate it. I can tell you that right now, that we don't understand the complexity and the soft skill side of it. So bringing everybody along and integrating everybody, it's just an enormous, enormous challenge. So I'm just going to end with that, and also just say, I've had the good fortune of doing computational fluid dynamics, wind tunnel testing, things of that, and it was a lot of fun. And when I came out of aero school, that's where I really thought, how I could make a difference in this industry. But I just wanted to echo what Ed said, is that there is a lot of technical sophistication and interesting problems to be solved by bright engineers that affect things right now. I mean, if you can come in and help us solve problems, optimization problems, you're going to start making a passenger experience better right from day one versus doing long-term R&D projects that may never see the light of day or may be just a fuel efficiency program. And I don't mean to diminish that, but you're not going to be impacting whether somebody gets to that wedding or gets to that funeral or makes their 30th anniversary because of our inability to plan. Or in next gen, I mean, that's part of why I got involved. Is it is so technically sophisticated and complex and so vital to our economy. It's an amazing opportunity for engineers, and I think for any of the young professionals here to consider in terms of helping us, bring on the best and the brightest to solve these problems. So with that, turn it over to Jim or Neil.
Jim?
Thank you, Tim.
It's the big one.
Yep. What I'm going to show you or try to convey to you is something that probably wouldn't be intuitively obvious. Normally, airport operators are considered more or less passive landlords. You'll see some of the activities that they do. But there's a lot more to it. And the takeaway from this first slide is strategic partnering. The reality is Tim, I think, quite well put out. These challenges of disruptions are quite significant, quite complex, and multi-scale. And so that said, I had the dubious honor of being the recipient airport for a flight that occurred in 2007 that led to the establishment of the Passenger Bill of Rights. That was Kate Hanai. She started off in San Francisco, was delayed on the ground there for a few hours, flew out to DFW Airport. Weather, we had lightning in the area and the like, and so she diverted to Austin and spent about the next 8.5 hours on the tarmac there without any attention, and then finally made her way up to DFW Airport. And that was a very unpleasant experience, and you remember all of that led to the DOT tarmac delay rule and things of that nature. She and I became close friends after that because we started to identify a lot of things that we, quite frankly, as an industry, were blind to. We really didn't understand what was the enterprise of what was going on, let alone because we didn't understand it, we didn't know what we could do about it. And so we elected to do nothing, quite frankly. So in the essence, there's a lot of things that were already in place. So when an aircraft is all of a sudden unworthy, there's an in-flight emergency, things of that nature, we have built-in processes that are established that all parties, the FAA, the airline itself, and the airport, receiving airport, are going to be notified of that aircraft in distress. They call up their alternate flight airport out of their flight plan, notify everyone, and on they go. And it's called an Alert 2 notification normally. And everyone is communicating, collaborating, and coordinating on that safety incident because the aircraft can no longer fly, right? Well, what happens when you have convective weather or severe weather? You have many, many airworthy aircraft, and it's the airport itself that is not flight-worthy, right? So what the common practice, because we didn't recognize what was going on, the pilots would go to the alternate airport, right? Because they're now being told you've got to divert, right? We can't take you at this airport. And so they'd all go, and there's Don Green, who operates Abilene Airport. He became my best friend, and he was the best friend of every aircraft that was coming across that corner post. He'd have upwards of 30 aircraft or so on the ground, and he got well known, written up, literally bringing out Domino's Pizza and the like. The reality was they overloaded that one airport, right? And that's the type of thing that happened to Kate Hanai, because there was not enough bandwidth capacity at that airport from the airline's perspective, the airport, or those contract service providers to accommodate those aircraft. So it was the recognition that, quite frankly, the airport was not in the loop. We were not talking to the airlines. They weren't really talking to us. The FAA wasn't involved. The contractors weren't involved, nor were any of the now 22 diversion airports. We didn't know how many we had, what was going on. And so we were totally disconnected because we were not aware of what was really taking place and nor how we might. It was, I guess I'd go to Tim's point, it was viewed as a problem that was too complex to solve, and it's a one-off, so why attempt to solve it, right? It just is what it is, get over it, it's going to be life. But that wasn't good enough anymore, right? So we had to start working together and say, what can we do about this? And so we did. We came together under a mode of strategic partnership to recognize that we have to provide a unified level of customer care. If, in my world, I got blamed for the Kate Hanai incident, right? And it didn't occur to my airport, but I was a party to it one night. You know, I was the intended airport. But if the airline or the diversion airport or the contractor or I or the FAA, whatever it was, we all recognized that the customer was expecting us to work together to solve these types of problems. And so we understood it's a shared responsibility. How could we step up to help each other? And so we understood that at the focus of this was communication. It was finally listening to one another, understanding that we all had a seat at the table, and from that communication become to appreciate one another through what we call collaboration. Why are the airports involved? Why do we even think of 22 diversion airports? There was not an appreciation for the role and the contribution we could make to one another, let alone how we might be able to coordinate our actions, take action on how we might deliver at the end of the day. And so we started to leverage existing processes and procedures that are in place. Everyone has emergency response plans that are mandated by the FAA. And when you look at those, we found out that those are for exceptional events. We just hadn't thought about them in this context. But all those types of procedures where we come together, as an example, with an aircraft down, we're all there, we're all in order to respond to those events. And quite frankly, we realized that irregular operations, in essence, are a subset of that. And these extended tarmac delays or exceptions were even a reduced subset of that as well. And so the concept there is, why are we not utilizing these emergency response formulative foundational pieces on how we come together, communicate, collaborate, and coordinate? Why are we not using those on an everyday basis? And it's the concept, I'm a retired Marine, so it's what you practice in peacetime is what you do in war, right? So these littler events were a way to us to reinforce those practices that are already out there, so that if we ever had an aircraft down, a mishap of something of that nature, quite frankly, we could be more effective under those events as well. But why not make use of those on a daily basis? And that was the grand aha. So we took that and formulated what we call a ground delay community, and included all those partners in there, even our concessionaires. What you'll notice is maybe there's weather up in the Northeast and we have customers spending the night at DFW Airport because they just weren't able to make their connection. And so our concessionaires will stay up late at night. Why? Because there's money in it for them, and the customer needs to be served, right? It was a practical win-win kind of scenario. Customs Border Protection, you have hurricanes in the Caribbean. American Airlines routinely puts on extra segments to fly those U.S. citizens out of harm's way. Customs Border Protection now gets that and keeps up, stays for the overtime because they understand the contribution they have to make, right? But also our 22 diversion airports are involved. They play a critical role in this. If we give them a heads up in advance, they understand that they make a contributing effort to say, this is how much capacity I have today. So that it informs the airlines, how about trying to distribute your flights across the 22 airports? And to Tim's point, they have to get done and wrapped up and ready to go for the next operational day. It's much easier to do that if you have 22 different runways with your flights distributed across, to get those back in a very rapid fashion once the storm or the weather clears at DFW Airport, as opposed to piling into Abilene with one departing runway, right, and trying to get those things reconstituted. So there's some grand ahas going on here through our collaboration. We went ahead and built something off this. I brought a couple extra copies if anybody's interested, but the Airport Cooperative Research Program, under the auspices of the Transportation Research Board, brought airlines, FAA and airlines, CBP, TSA all together to really map all this out so as it serve as a go-by of details on how to get this accomplished. Having said that, I go back to that C cubed, right? What it really means is we started with the end in mind. Where is the customer in all this? Whether that be an air traffic controller, a pilot, the people that are on that aircraft, the SOCs, the Systems Operations Centers for the air carriers, et cetera. What are the customer's needs? And even diversion airports, what are their needs? What are their capacities? What's the host airport, et cetera? We're all customers to one another. That said, we begin with that. We share that across the Irregular Operations Network, and we come together and identify in advance through sharing our current plans and procedures. And that means that some of them are legacy procedures, but some of them are really, quite frankly, silo-based, aren't they? FAA does air traffic management. Well, that's what they do, and that's what their plans are oriented to. We have the airlines with their flight plans that they upload with an alternate airport embedded in them, but that's about an unworthy aircraft event. but that's what they're built upon. Heretofore, they were not cognizant of this idea that this aircraft is still totally flight worthy. Maybe I have to modify my current plans and procedures in this kind of an event. So there's an eye-opening that came from that sharing. And so we begin the pre-planning. How are we going to support one another before, during, and after an event? We train to that. We're going to do things differently. So we're going to have to train up to how are we going to actually conduct this affairs, especially with our frontline staff. We then go ahead, and it's what Bill indicated today. Once you're done with the pre-planning and all that, it's all in the execution. But having said that, as Tim pointed out, and as Ed Bolton started out today, we're in a brave new world. This transformative technology that is enabling us to do far more than we ever thought or imagined with air traffic management is, and as Tim pointed out, highly complex sets. We're learning and growing. And so let's approach it at this. Instead of pointing fingers and laying blame in hindsight, armchair quarterbacking, why don't we recognize where we are? We're just learning how to ride this bike. And so the more that we go ahead and say, take an objective view as we go forward after each one of these little events, we're going to learn and grow and be able to do better over time. And so then we're going to share that out and becomes the next industry best practice. And of course, then it's first to market, first to win. Whoever's got the next best idea wins. We share it with one another, and hopefully that's going to create a next best idea, and we all win. So that said, we actually built this out and executed it. And I think the big deal here for those folks who are providing systems is that item up in the upper right-hand corner, real-time shared situational awareness. I will tell you with NextGen, we're not there yet. We're trying. This latest effort on the part of RTCA at the request of FAA for PBN Blueprint and that brought in everyone together in the industry in a way that this did as well. But it all came down to appreciating one another's world, how we do business and how we execute on that, and knowing how to support one another effectively. And the bottom part of that little roadmap there, if you will, is the iterative approach. Every event, every day is a learning encounter, isn't it? And so that means that we're going to have to be real-time communications with our FAA partners and our airlines all day, every day. And that's why at DFW Airport, we have a 24/7 airport operations center that's in communication with American Airlines IOC, the FAA Center, TRACON, and involved in airport collaborative decision-making, as well as all the SOCs for all of our carriers to make sure that we're all understanding and learning and growing as we go. Here's the challenge. If we are living in our silos, if you came out and you think of just my world and that's all I'm going to focus on, we're all going to lose here. This is where we were a number of years ago. Everyone does their job and everything's going to be fine. The world has changed. And it's gaining that appreciation what the new world is that I think is essential to this audience to understand. Until we got an appreciation that we had to get past that mindset, we were failing. And it's only as a community when we got past that mindset and got over to the left-hand side of that curve that we really started making gains, and I think we made some substantial gains as a community. That said, there is a chasm here in the middle there. And the bottom line to this is, okay, I'm all into understanding where you're at, but I'm still going to do business as I know it. That's that legacy system maybe. It may be that you're in the system and this is how I know how to do things. I don't feel comfortable in getting out of my area of expertise. There's a risk factor if I go outside the bounds of what I've been taught and what I've been doing. That's where that learn and grow comes in. It's the willingness to step out, take an informed risk. We'll take the consequences. I think we're all up for those consequences because we have to move forward. And we'll take it as an opportunity to learn and grow from that. And that's the essence of this. If we don't do this right, we're never going to succeed. And this applies to NextGen as well. And this last year's effort with PBN, I think we all got outside of the box on this thing. And I think where we are collectively is trying to operate on the right-hand side of that curve. That said, this takes time. And we're seeing in the PBN deployments, we're seeing in an IROPS development, this has taken years to come and inculcate this understanding. And the premise is when we have a bad event, we're not pointing fingers. We're learning from it. We're going to apply and those tools, techniques, resources that are going to enable us to succeed on an onward basis. And I would offer this to you. If we're doing it every single day and it's on the small things, Quite frankly, the risk is a lot lower, and we're learning and we're reinforcing to every frontline employee in building muscle memory on how we're going to socialize and partner with one another as we go forward. So when the big events happen, we're ready to stand tall in a real-time way to better serve our major partners, right? And so with that said, I go back to that. This is not a one-off. It goes back to what Bill said. You can put a nice plan and put it on a shelf and it gathers dust. This thing can go on a shelf and gather dust. It isn't meant to do that. It's meant to be executed. This is a starting point, but the reality is if you don't take it in here and start really collaborating, this thing all dies. But that's what it's intended to do, reinforce the partnerships. The opposite is true as well. If you don't reinforce this sort of philosophy, this mentality, and how we're going to do business, we're all going to fail, and we know this. And the reality is you got new entrants coming in, people taking on new assignments. Tim said he looked at the different, I don't think, if you asked Tim if he saw himself coming out of aero school, did he see himself in the role he's in today? Probably not. Life takes a lot of twists and turns, so when you come into this community, we recognize that every season, every day, we have new entrants coming into our community. They don't get what I just got done talking about. They haven't suffered the consequences of a Kate Hanna incident. They haven't suffered those lessons learned yet. And so we bring them in, orient them to our community so we can go do this. Otherwise, we're going to fade. Now, here's the good news and the bad news, right? The good news is that we're learning creatures. And so now that we've got this stabilized like this, quite frankly, all the air carriers are now energized in terms of doing better, getting to that predictable state, getting to that optimization that NextGen is going to provide us with. I dare say this kind of community collaboration is absolutely essential to the deployment of NextGen, and more so development of the systems, because it comes down to, if we're going to deliver on all these events on a daily basis and do so on a regular basis to get to that steady state of better optimization, if you will, and serving the customer, we have to do some things. We have to come in, reinforce, and get aligned to this even better than we've ever done before. But here's the challenge, and I leave this with you, and that is that this shared situational awareness is not an easy event. We're, I think, in the early stages of life right now. There's a lot of transformative technology for equipping airplanes, as well as communicating, collaborating, coordinating, sharing essential elements of information with one another, understanding where each world's at. But as Tim pointed out, these are disparate systems right now. Or the business models are set that they're in a siloed fashion. If you just buy our system and replace everything you've got and go with what we have, life would be better. That's not a realistic world. So that said, I pose a challenge to folks in the era of rapidly changing transformative technology that's being reinvented almost daily, is the real challenge of how can you enable this broad community into what they have and provide better situational awareness of what each other is doing so we can be better supportive of one another, not just in irregular operations, but during the regular operations that we have on an each and every day basis. So thank you.
Step by you, please. Excuse me. Good morning. I'm going to deviate a little bit. Just by show of hands, who traveled from Asia to be here today or this week? Very nice. Thank you. Long ways. How about South America? Europe? Australia? Dallas? Fort Worth? Okay, good. And how about representation from the different disciplines? Engineers in the room? All right, most of you. Thank you. Military? Thanks, Major. Any pilots in the room? Very good. Finance? Press? Lawyers? I might need
That's
the
really
lawyers
what he
after the press. Well, good. Well, thanks and welcome. It's an interesting topic. We're talking about disruptions in the airlines, and I just can't think of a better group to be talking about disruptions, because we seem to do it pretty well. Get into disruptions, not necessarily navigate around them. So I'm the pilot on the panel, and you know, we were talking before that a lot of times pilots don't understand everything that you do behind the scenes to pull this off. And it's an interesting perspective because pilots see the operations from start to finish, right? They do the pre-flight planning. They're engaged with the network ops center and the dispatch team. They make sure that the fuel is correct. They make sure that the maintenance is correct on the aircraft. They make sure that the weather is going to be suitable and that the requirements for the airfield departure, destination, and alternates are appropriate. They engage the passengers, the flight attendants, they fly the aircraft, they get to the destination, they say goodbye to the folks. But they rarely understand truly what goes on behind the scenes to pull this off and make it work. So we'll talk a little bit about that. And it occurred to me as the other gentlemen were speaking that there's so much overlap about what we could talk about. I'll try to cover things a little bit differently and hopefully in the question period that you'll be able to pull out some other interesting details. But as we're talking about irregular operations, we would like to think that we can avoid them, but we simply can't in this very complex business. So most of these things occur for all the reasons that you would think of. So it's either bad weather, as Tim and Jim spoke about, or systems failures not only on the aircraft, sometimes it's at the airfield, sometimes it's in the national airspace system, sometimes it's other things that fail. So a lot of it's internally our platform. Sometimes it might be a security event, a logistics event where we don't have the proper supply chain available if a part breaks on an airplane and we're at a location where we don't have that available. So it could be a whole host of things. I put this up here just to show the complexity of the network, and Tim did it a little bit as well. And so Tim made the point that if weather is affecting one hub, it's probably not that big a deal. But that's not the way it works in the airlines. So, you know, and you can see up here that we have hubs in San Francisco, LA, Denver, Houston, Chicago, Washington, and New York City. And typically for us at United Airlines, we have at least 3 airports in some sort of major weather. So San Francisco, although they don't see major weather, they do have a problem with flow of aircraft into San Francisco, and it's largely due to the coastal fog that occurs in San Francisco. So we plan to have the coastal fog lift around 11 o'clock in the morning, and then we get to an arrival rate that we can sustain the operation and fly the schedule. If that coastal fog doesn't lift, because of the closely spaced parallel runways in San Francisco, then we typically are not able to get to the arrival rate that we need. And then if there's major weather either in Denver, Houston, Chicago, a thunderstorm, then that further complicates the system. And as Tim said, if it's a winter event, we typically know it's coming, we can plan for it. If it's a summer weather event, we don't. And I actually thought that I might be having to call in today because last night I was in Chicago, and if you saw the news, there was a major weather event in Chicago, tornadoes and the like. And so what we did to plan for that event yesterday is we typically try to take capacity out of the system because we know we're not going to be able to get to the airport up to the arrival rate we need. And so in the airline business, there's not weather that we typically can't fly in. The only really dangerous weather that we avoid is convective weather. If it's a snow event, we can still fly in it, but it's going to be at a reduced rate and a much slower pace. If it's low visibility operations, we can still fly in it. But if it's convective weather, we won't. So what we're typically trying to do is manage to an arrival rate that the airport and the airspace can sustain to get the traffic into and out of the airport. And so last night, we knew that the weather was going to be bad in Chicago, so we took out a lot of capacity. And the problem with last night in Chicago was the timing of the event. We knew that there were going to be thunderstorms, but we didn't know when. So the complexity of that operation caused us to reduce our schedule, but we reduced it at the wrong time. And so when the major weather impacted the station or the airport, we weren't really in the best position to deal with it because we had regenerated our flying at that point, and it was very difficult for us to manage the operation. So this is our international operation, our international network. And so you can see that we're like American and Delta and all the other legacy carriers and the international carriers. We're spread out throughout the world. And if there's a major event or weather system in any of our gateway stations or our large international stations, it's also complicating the network. If that airplane doesn't make it back from Europe, then it can't turn on the flight that's supposed to fly out of New York City or Chicago. And you'll notice we have a pretty robust operation in Guam. We have a hub there for our Micronesian operation. If there's a hurricane or tropical weather there, it also disrupts our network. We can't connect passengers to where they need to go. We prioritize our flying in order to protect revenue for the airline, but to accommodate the passengers. And so like most business models, we tend to focus on the premium passengers the most because they generate the most revenue for the enterprise. It's not to say that everybody else isn't important, but we have a need to make sure that the folks that fly with us the most are protected. And so we do that in various ways. One of them, when we're talking about capacity reductions, is that we prioritize our airline primarily with our international flying first, then our hub-to-hub flying, then our hub-to-line station flying, then our express partners. And like most airlines, most of the legacy airlines, our express partners cover a huge portion of our network. And so for United Airlines, we have 10 express partners. When we start taking capacity out of the system, they typically get affected the most, the quickest. But we have to get to that arrival rate that we can sustain the operation. So just a glimpse of some of the people that we work with in the Network Ops Center, which is kind of the command and control center for the airline, are all the people listed up here. And the pictures there represent what happens at the Network Ops Center. So as the managing director of flight operations is the pilots division, so everything that is touching what the pilots do. And so I interact with all these people in my job, and I try to give them the pilot's perspective of what they need to know and understand. And so in my job as managing director of flight operations, my biggest concern is the operation from the pilot's perspective. And so I categorize that into really three areas. One is the current operation, what's happening today, how do we get the job done? The second one is contingency operations. And contingency operations could be anything from a high-value charter mission to things that we know that are going to occur in the system that will slow us down. And so we may sometimes need to stand up our emergency operations center to cover those contingencies, and I'll speak about that in a minute. And then the last part of the operation is the emergency operations. So in our Network Ops Center, we have an emergency ops center. Thing is going to occur that's going to disrupt the system is that we'll dedicate certain resources to our emergency ops center, and we will activate it for a short period of time depending on prior to the event. And so these events could be anything from something that's happening internally at United Airlines, something that we know is going to cause chaos in the system. So Hurricane Sandy or something like that we knew was going to hit New York City, and therefore we stood up the emergency ops center for a couple of days to be able to handle it and offload some of the network ops center folks. And then other events internally might cause us to do it as well. So Tim mentioned FAR 117 implementation. It was a unique experience for us because FAR 117 and the law that was put in place in January a year and a half ago caused us to really have to focus on things that we didn't have to do before, and I'll explain that a little bit. It used to be that if pilots were legal to start, this is in the US, if pilots were legal to start, they were legal to finish. Now, if a pilot is legal to start, they're only legal to finish if they can get off the ground, accounting for the flight time that Tim talked about, to make it to their destination in time, to get there prior to their flight duty period ending. And so the complexity of that is that you have to, one, know the flight time, as Tim mentioned, and part of that flight time that you see in our block schedules is predictive taxi time. And so we also have to know what that taxi time is, because it's all baked into the block time. It just makes it very complex. So we'll stand up our emergency ops centers for these things, and we're pretty effective with it. External coordination, station ops. As Jim mentioned, all the airports have a station ops control. We work with them. We work with the airports, our express partners, and other folks. And so there are planned and unplanned events, right? So the planned events are things that we know about, things that we're doing internally typically. And so when we implemented FAR 117, it took an incredible amount of programming effort. When I asked you to raise your hands, I left out the programmers, but thanks for what you do, because we couldn't run this business without you. So if we know it's going to happen, we plan for it, we do everything that we can to prepare for it, and we'll utilize the resources to make it happen. So some examples of some of the big disruptions that we've had. So these are some of the things internally to United Airlines. We, as a result of the merger, and Tim spoke about this a little bit, as a result of the merger between United and Continental, you inevitably have to choose one of the legacy systems. The interesting part of the airline business in the United States is that the regulator gives us a set of rules to operate to. And it's up to the airline to operate to those rules and to be compliant with the law. And you can do it any way that you choose, as long as the regulator sees that you're operating to the rule. And so it's amazing in this business that two companies that look so much alike, United and American, would operate so differently. As long as we're compliant to the rule, we can do that. And so all of these internal things that we've done are different, and Tim spoke to the legacy systems that we utilize to operate the airline. They're so complex, they're all rooted in 1960s and 70s technology, typically Fortran or COBOL, and it's really difficult to keep these systems up to speed with all the other technology that's available. It's the platform, the database that we use to run the airline. And so we've migrated most of our systems as a result of the merger, and the programming work associated with that has been very complex. So you may have heard a couple of weeks ago we had a flight planning system failure, and so what was happening was that one of the programmers from our vendor was doing some programming in the test world, and somehow it migrated out into the live world, and so some flight plans were issued that weren't live flight plans, but they were tied to certain flight numbers, so we had to shut down the system for about 20 minutes and quickly get to an understanding of what caused that event. And we, at that point, activated the Emergency Ops Center, and we got everybody focused on what we needed to do. There's external events too, and so we tend to think of all the big events that drive irregular operations and the disruptions. And so some of those that come to mind are the Chicago Center fire that occurred not too long ago. The Tokyo tsunami caused major disruption. There was a huge thunderstorm event in Denver. And then we constantly have airports under construction. And so one of the things I'd like to just bring to your attention, and perhaps we can talk about it a little bit later, Neil, is that we tend to focus on the big events that you see in the news. Those are really, if you look at a distribution of these events, those events really are in the tail of the distribution. We focus on those because they're big and noteworthy events, and they're important, don't get me wrong. But if we're measuring risk in terms of severity and probability, then the probability of those events is pretty low. The severity is huge. We still have to maintain awareness, focus, and be able to handle them. But what we really need to do is to focus on the things in the center part of the distribution curve. And the center part of the distribution curve are everything that we deal with daily, and there's thousands of them in the airline business. And so we need to really get to, so one of the things we were asked to do is to think what we really need in the airline world to help us better operate through disruptions. And for me, it's this one thing. I think that the airlines are very good with descriptive data. We can tell you what occurred. We can tell you, when, why, what occurred. We're not very good yet at getting to prescriptive analytics. We need to be able to take that what, when, and why, to build options out of that, and to drive options that give us the best outcome. And if that's the one thing that I could share with you, is that's what the airlines really need. That's what the airspace really needs. So with that, let me turn it over. Thank you very much.
All right. Thank you very much. Brian, thanks for pointing out the press and the lawyers before the Fed got up to run his mouth. I appreciate that.
My pleasure.
Keep myself from getting into trouble. So I'd like to kind of talk about a lot of things from a systemic point of view and weave in, the NAS-wide perspective related to the problems that my partners here are facing. And I'll talk about, obviously, that weather is our main impactful event in the NAS. And let me just start by saying, we run a very good operation across the country. We're running 45, 50,000 IFR operations a day without any delay really to speak of on a good day. And so the area to focus for us is on these irregular operations days where we run into a problem and we start seeing these delays that are fairly extensive. The challenge for us really is to try and figure out how to engineer a system that can deliver a normal day under a constrained condition. How do we make an IROPS day look like a regular day? And it's about, for me, a couple of key areas, and we'll talk about that. In addition to the customer problem that you have, the dissatisfaction and the disrupted networks that you see with your airlines and impacts at the airport, I had my staff take a look at the delays that occurred in 2014. And what I see is 110 million minutes of delay in the system related to weather at a cost of about $8.3 billion to the industry. So aviation is an economic engine, and the engine needs a tune-up on these kinds of days. This is what we need to try and get around if we can figure out how to run a better operation. And then you have your dissatisfied customers, and then you have your disrupted networks as well. But we also introduce irregular ops into the NAS purposefully, and I'll talk a little bit about some of that. I'll give you some examples of how we do it with equipment as we usher that in, and folks are trying to learn how to adjust to the next gen related equipment. We'll talk about the construction, and you'll see just quite how impactful that is. And then I want to talk a little bit about the unexpected things that we have. We have equipment failures, just like my partners here. We have these unexpected events, and are they without cause, or are they related to something that we could have prevented? In some cases we have outages. I'll describe what I call an ATC alert and ATC 0, and you can't get around a tornado when you have to evacuate your tower. Well, you're out of business, right? But there are other things that come up that impact our operation. And finally, I want to talk a little bit about some of the global considerations. How far do these networks extend? You saw these the airlines networks that go internationally. These are very high revenue operations for them, and what goes on out around the world outside of our borders is pretty important to us and the networks. So let me talk about the weather impacts here. For me, the major improvement that we need, the solutions that we need from the engineering community is around weather forecasting and predictability. This is our Achilles heel. And if you go back 15, 20 years ago, we have seen great improvements in our tool sets here. But Chicago was a prime example. It gives us a great example from last night, what happened at Chicago. And what we tried to do yesterday when I got a briefing from my team in the morning was we knew that the thunderstorms were going to come in and hit the field. We thought it was going to be pretty much a direct hit. And so what we're trying to do is time the traffic and stop it from arriving when we know the field's unable to receive any traffic. Generally, we do a ground stop, and we'll put that in for a few minutes or 30 minutes or an hour and a half. And you get into these rolling ground stops, and what happens is it wrecks the predictability for the airlines. So what we tried to do yesterday was run, in essence, a ground stop, but we called it a ground delay program. We put in a 7 arrival rate for the 11 o'clock local hour. This is an airport that runs 106 arrivals in good weather. And then we wanted to walk our way out of that. I want to read to you a comment, because we ask our customers for comments at the end of each day. And let me get this to come up here. And I'll describe to you what really happened. We put in the 7 or 8 at 11 o'clock, and guess what? The weather came in a half hour earlier. And of course, we weren't prepared for that. So what happens to the inventory that you have in the air? Because we're trying to jam them into the field in front of the thunderstorms and clear out the departures so we don't have some kind of surface congestion going on. The weather came before we were ready for it, and Now we're into holding. Now we're into diversions. So we're not running the operation the way we want to. The 7 rate for the 1100 hour, we actually landed 62. So we have some pretty good tools to allow us to deliver 7 aircraft in an hour. We had 62 in the inventory. How did that happen? Where'd they come from? Okay. The next hour, we were stepping the rate up. So we would go up to a 26. We landed 29. And then the next hour, we wanted to go to a 54 rate, and we only landed 38 because we've already put in a program and we've disrupted the whole network. You get into what's called unrecoverable delay. Let me just pull up this comment from the customer, and I want to read this to you. Sorry for the delay here.
You're concerning me that this might have come from us.
It's either you or me.
It will be nondescript, okay? And
Maybe midway.
I have it in Braille font, so give me just a minute. Here's what it says. Kind of a difficult morning figuring out what the weather would do at Chicago. Thunderstorms ended up not being a problem at the airport. We thought it was going to be a direct hit. We thought we were going to have lightning strikes at the field, and the crews are going to, come off the gates. Didn't happen that way. The GDP wound up a bit too restrictive. I'd say so, a 7 rate. All right? And as the forecast weather didn't happen, oh well, sorry for that, right? We need help. We need help with our predictive tools. This is the area that we have a real problem. We have some good stuff like I mentioned, but for us to be able to manage this system well, we need to know what the impacts are going to be. We need to know the data like, 60 minutes out to 120 minutes out. What is the real demand on the airport? I need to know when the winds are going to come in and shift. Have you ever seen a runway change at Chicago? A dramatic runway change when you're all lined up over on this side of the field and now you have to go to that side of the field? I need to understand the runway conditions. What's the braking action? That's a pretty subjective piece of information there. And I know you can do it with tools. I've seen some experiments that have been going on that would allow me to know from the equipment on board the airplane exactly how long it takes to slow the airplane down. But we don't have that in place. These are the kinds of pieces of information that we need, and how do we get that and how do we exchange it, and then what do we do with it? I've got the information. How am I exchanging that with my counterparts here? Right now I feel like I'm fairly ham-handed. I come at it with a meat cleaver. The rate at Newark is 34. Well, why not 35? One airplane could make a difference. What's the actual runway occupancy time? How quick are they taxiing off? After 2 or 3 of a similar type aircraft, I really know how long it takes, and yet I don't change my arrival rate, and I don't exchange the information. Maybe it's easier just to stay status quo than to try and do this fine-tuning. I don't really know, but can you take advantage of it? If I could share the information, could you take advantage of that? Well, anyway, we ended up with diversions and holding, and it didn't time out right as we had hoped. The one thing that was beneficial in this case was that the GDP gave some predictability to the customers where a ground stop method would not. And so we did collaborate with the customers, but we didn't end up where we wanted to. So this is an area around weather, but I want to talk about a couple of other things here. What I would call purposeful irregular ops. So Los Angeles, we had a closure in the spring, and we'll go into a closure on Sunday, the next phase for Los Angeles. These are mandated events that are going on the runway safety areas, and we're walking across these runways one by one. For Los Angeles, in the spring, we ran a ground delay program almost every day. That's what we do, in a severe weather event. So this runway closure is really an irregular operation. And we've taken, there's IATA levels where you get to become an airport that's fully scheduled, slot controlled. We have 4 of them in the country. But we have several of them that are level 2. It's sort of an in-between. Level 3 is fully slot controlled. Los Angeles is going to level 2 on Sunday because we need to begin to look at the scheduling information because there wasn't a significant drawdown by any one player at the field. And LA is a little interesting in that there's not one dominant carrier. And so it's fairly spread out, and there's a lot of international traffic as well. So there weren't a lot of changes to the schedule, but we've lost a 25% of the capacity. We know it. And what are we going to do about that? As a community, are we approaching this the right way? And if that's what we intend to do, are we advertising this to the flying public in a way? Do we have a kind of a standard campaign at least to go out and say, hey, here's what we're going to do? I'll give you an example. At San Francisco, they sent out postcards to thousands and thousands and thousands of their customers a year ago when they went into construction. They were very, very proactive in trying to get the word out. But this is potentially more damaging than you think. This is what we intend to do over the next couple of years. A lot of our major airports are going to see construction, and these are long, months-long type events. Seattle's in construction right now. Seattle Airport has got 3 runways. The center runway is out for the next several months, and traffic is up 27%. It's a difficult operation. They're doing very good. Kennedy's under construction right now. Again, 4 runways. We're down, we're down 1, and they're running 75, 77 operations a day up there per hour in a slot-controlled airport. It's pretty significant what they're doing. So our plans, we do some pretty good coordination with the customers on this. We meet with the airport authorities and we talk about what we're going to do. Like I said, when I went to San Francisco, John Martin there runs the airport, came to me with a book and he said, look, here's exactly what's going to happen to us. I know what the delays are. I know what the taxi-out time is going to be. We've already modeled all the impacts. We know what we need to do to manage it. Conversely, and not the delay, it was the reverse. It was as if they hadn't even begun to plan, and we're getting ready to go into major construction there. JFK of 5 years ago was well advertised and planned out and well managed, and now we're criticized that we were kind of behind the power curve on Kennedy this year. At Fort Lauderdale a few years ago, we did a very good campaign. The point of all of this is, what's the standardization? How do we go around, and this is not an uncommon thing. How do we get the information out and build a checklist and work with our partners? You've got a good operation here. You've got a very close-knit activity going on with your community, and you bring them together well. Other airports aren't, as proactive as that. And so we end up with delays and results in irregular operations. Another area where we actually draw down the system purposefully is when we implement new things into the NAS. So in this case, when we bring in equipment like our surveillance equipment or maybe our display or a new voice switch, what we'll do is we'll take a look at the impact, we'll talk about what we have to do to ingest this system into the control room, and then we've got to get our controllers trained up on it, and they're on schedules, and it takes several weeks to cycle everybody through. Often what we do is about a 4-week drawdown of the system purposefully. We put out a system impact report, we meet with the customers, and we talk about what we're going to do. I'll give you a good example here on the procedures. We put in some OPDs into Minneapolis recently. And what we did there, we have a sequencing tool, time-based flow management, and there's a freeze horizon on that tool. So after a while, they don't want the controllers to tinker with this thing because you got to actually get them all lined up to land, right? And you're done with your sequencing and now land instead of maybe 100 miles out from the airport. In this case, when we implemented these new procedures, we moved the freeze horizon out 320 miles. We were already out in Chicago Center's airspace with this activity. And at the same time, these two facilities, Chicago and Minneapolis Center, weren't familiar with what we call adjacent center metering. And so they were trying to do this new procedure while they implemented the approaches into Minneapolis. Unfortunately, here was the unintended consequences. And believe me, there was a lot of conversation. There were a lot of meetings with the customers, with the airport authority, and with the controllers. We locked down all of the internal airports up there. And we had flights that couldn't get off the ground. Fargo, no departures. There's no place in the overhead stream for them. And we had like a revolution on our hands, The customers were in an uproar. This went on day upon day upon day. And I said, you're killing me. I got people that don't even want to come back and fly with me anymore. There's no spot in the overhead stream. When you work in the airlines and you bring in new equipment or you do new procedures, you're generally doing that in a simulator. maybe that's what I need, is a better way to simulate the implementation of these tools and procedures. We try and do a little of that, but clearly we didn't uncover this piece here, and it was very costly. How do we go about doing that? And then when we do it, let's say I do have a robust simulation capability. Am I just doing it with my own team? Or maybe I should have the rest of the partners involved in this discussion in the lab with me, trying to figure out how to improve this.